Hello and welcome. In this video, we are going to take a look at how to capture the parts of a MAC address using Matlab's regular expressions. The idea here is that for some reason you want to capture the MAC address associated maybe with a particular network card, perhaps as the result of the command out or running a command and capturing the results in Matlab, or perhaps some text that you have to parse looking for all MAC addresses in the text. To begin with, this video assumes a couple of things: that you have some familiarity with MAC addresses and the media access control layer in the OSI model. The MAC address is essentially an address or a unique identifier for your network adapters in your computer. And the second thing that it assumes is that you've got some familiarity with regular expressions in Matlab, and particularly this meta character language and the quantifiers associated with it. Now, to begin with, let's go ahead and take a look at what is a MAC address, or an example of a MAC address. Essentially what it is a hexadecimal representation of the hardware ID. The pattern that we're going to be looking for is going to be pairs of hexadecimal values separated by either colons or dashes, depending on which operating system you are on. Specifically, you're going to be looking for 6 pairs, and those individual hexadecimal values, of course, can range from 0 to F, which presents us with an interesting challenge because we will be looking for digits as well as alphabetic characters. Now, we're going to play around a little bit with this. This is not going to cover all of the possible regular expressions that we could use. If you have some familiarity with regular expressions, you know that there are tons of neat ways to be able to capture patterns. Arguably, the way that we're going to look at it is going to be relatively inefficient. In other words, a little bit on the brute force side, because this is going to be our first exposure with capturing MAC addresses. And so to begin with, we want to take a look at the meta characters that we could possibly use. You could, for instance, use the period, which is going to be any single character, including white space. But the problem with that is it's a little brute force. In other words, a little bit too strong or too greedy, meaning that it could look for characters that we were not interested in, or possibly patterns that we were not interested in. Now, we can mitigate this a little bit by looking at the /W, which is going to be any alphabetic, numeric, or underscore character, and combine that with the fact that we're going to be looking for a specific number of them using the quantifier, where we can specify exactly n times, or in this particular case, exactly 2 times, then followed by either a colon or a dash. We will be pretty confident that it is going to be unlikely for us to find too many other results that don't explicitly match our MAC address pattern. In other words, it's going to be hard to find text that will also match the pattern that we will build, simply looking for 2 alphanumeric characters followed by either a colon or a hyphen, followed by 2 more alphanumeric characters, and then we repeat this multiple times. So let's go ahead and get started. Again, we're going to use the /W, and we're going to use this quantifier that allows for us to specify exactly n times, or exactly 2 times. All right, so to begin with, let's go ahead and get a variable for the MAC address itself. I'm going to go ahead and just use a MAC address off of my computer. The idea here is that you could possibly run your ipconfig /all on a Windows machine, or on a Mac or on Linux, the ifconfig, to be able to capture one of your MAC addresses, or basically any combination of hexadecimal values, again, separated by either dashes or colons. Since I'm on a Windows machine, it's going to be separated by dashes. Now, the second thing that we want to do is go ahead and create our results variable. We're going to use our regexpi function again, and we're going to pass to it the MAC address as well as some pattern. Now, if you're not familiar with the Matlab built-in help, we can also use that. We can scroll down to the same table that we saw online. And as I mentioned, we're going to be using the /W meta character followed by the number of instances that we wish to match consecutively wrapped in curly braces. And so what we'll do here is we'll look for our /W curly braces 2, which is going to match the pattern of any alphanumeric character twice. Now, as you can imagine, that's going to be a very generic pattern. And the other thing that we want to do is we want to wrap this then in a set of parentheses to indicate that we actually want to grab the token itself. In other words, if we don't use the parentheses, it's going to match the pattern, but it's not actually going to capture anything. And so if we run this then, particularly with both variables, then you'll see that I have a 1×6 cell array. And if I drill into that 1×6 cell array, we can look at the individual cells, both by specifying the first index, or we can use then a combination using 2 sets of indexes, or curly braces 1, curly braces 1, to get the individual value in this nested cell array. Now, a quick reminder, if we were to take a look then at this, we have a 1×6 cell array where there is in fact 6 cells, and then embedded in each of these cells is another cell. And so what we would have to do then is that we would have to specify which of the cells we wish to access simply by specifying curly braces 2. If we wish to drill into those cells, then we would do curly braces 2, curly braces 1. But if you notice here that what I'm doing is I'm essentially picking out each of the individual pieces in our MAC address. So in other words, results curly braces 3, curly braces 1 is the 4B. I think at this point you could probably guess what 5B would result in, and that is the 84 associated with this MAC address. And effectively, you can see that we're capturing the individual pieces. Now, that's not quite what we wanted to do. So let's take a second to now modify our regular expression. Now, with building regular expressions in general, I encourage you to sort of do these piecemeal, in other words, one piece at a time, rather than trying to figure it out all at once, because that can get a little frustration. Can result in a little bit of frustration, excuse me. And the idea here is we want to look at the pattern in pieces, and you'll notice the next step of it is to simply include then the dash. And then go ahead and rerun it one more time, and you'll see that I now have a 1×5 cell array. And specifically, if I look at the individual pieces of the results, I can capture now my 8C, including the dash. And if I look at the second one, we have our EC and then dash. Now, you're probably wondering what happened. Well, why aren't we capturing this last value? Well, it turns out since it isn't followed by a dash, we aren't capturing it. So effectively, we've lost the last part of our MAC address, which then allows for us to move forward to think about how we would go about capturing the rest of the MAC address in its entirety and not just piece by piece. Well, what we do is we essentially duplicate this pattern multiple times. And so what we'll do is we will simply copy and paste this. And so now what we're going to be doing is we're going to be looking for 2 alphanumeric characters followed by a dash, followed by 2 alphanumeric characters, followed by a dash. And again, I encourage you to go ahead and run this before we go any further. And you'll see that I'm now down to 2 1×1 cells, which might seem a little discouraging, but you can see based on the pattern's results that we effectively don't have enough dashes to be able to capture the rest. In other words, we can capture this first pattern. I accidentally dragged and dropped there. We can capture this second pattern, but because this 69 does not have a dash after it, we can't capture this last portion. But hopefully at this point, you've now started to see what we're going to do, and that we're just simply going to repeat this /W curly braces 2 followed by the dash multiple times. So 3, 4, 5, and then 6. But the 6th time, we do not include the dash. And now, if you were to run this, you will in fact capture the entire MAC address. And if we look at our results, curly braces 1, you'll see that, yes, in fact, I have captured the entire MAC address. Now, again, there are other regular expressions that you can use. And one particular example that you can use is going to be involving the range of meta characters. Now, I encourage you to think about how you would go about doing this. And effectively, what you would do is you could specify all of the potential characters for a hexadecimal value. In other words, what you would do is you would include everything from 0 up to F. And again, I'm going to do this once here just so we can see it. This particular pattern would get arguably too long. Let's go ahead and give this a shot. And so what we would do here is we would say results then would be equal to regexpi. We would have MAC address. And then what we would do is we would simply specify using curly braces all of the values. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, followed by the closed bracket, followed by the curly braces, which indicates that we're looking for exactly 2 of them. And again, we could provide the tokens argument. And if we run this, we get a 0 by 0 empty cell array. Again, here we'll need to go back through and figure out where we have made a typo here. 1 second. Yes, there we go. I missed my parentheses. One of the things that you're going to discover is that regular expressions are both very powerful and very vague to work with. In other words, you're not typically going to get an error if you have a poor pattern. It's just not going to be matched. And if we run this now, notice now I have the second parentheses there. We have our 1 by 6 that we had earlier. In other words, we've effectively matched the same pattern. But the advantage with this one is, since it is more constrained, because it is very explicit about what values to match, then it is unlikely that you're going to get a false match with your regular expression on a MAC address. In other words, let's say that you have a MAC address for whatever reason, it wouldn't be valid, but with the letter Z as in zebra in it, well, it's just going to be ignored because it won't match this pattern. And if you want to see what I'm talking about here, we can actually change this to the letter Z, which again is not a valid MAC address. And if we rerun this one more time, you'll see that I am in fact not going to pick up the 8Z. So we can do our results curly braces 1, and you'll see that it skips over that. So again, what we want to do is we'll go back, we'll change this to a valid MAC address. And you can see what I'm talking about this getting rather long, because what we would have to do is we would need to add the dash, as well as providing 2, 3, 4, 5, 6 copies of it. And again, we would remove the dash. And while this is arguably very, very good, let's make sure that I don't again have another typo here. Let's one more time count. 1, 2, 3, 4, 5, 6. And again, I seem to have included a mistake in here. Let's see if we can figure out, that is because I did not rerun the MAC address. I still have my old broken MAC address. Let's run this one more time. There we go, a 1 by 1 cell. And again, we have our results 1. Now, again, there is other ways to go about doing this. You can go back and you can actually make a quantifier associated with an entire longer pattern. But again, this gets very complicated very quick. I don't want us to go down this road in this particular video. Again, there's all sorts of neat ways that you can do regular expressions. Hopefully you think of this as somewhat of a little bit of a puzzle to figure out the pattern. And again, just to emphasize that if you are on a different operating system or you have different source, you can easily just swap out this dash then for a colon. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.